This video is to tell you about the hydrocarbon molecules that we call alkanes. This is a group of molecules that have a carbon chain and they're found in crude oil. The first alkane in the family is methane. Methane you've come across before, and it's a very simple type of molecule. So it contains just one carbon atom in the centre and it's surrounded by 4 hydrogen atoms. We can show this in different ways. So I've got my carbon atom in black in the centre, and I can show this as being surrounded by hydrogens. Now you'll notice that what I've drawn is the same as the 3D structure of the molecular model, but all that seems to have happened is I've squashed it flat on the page and I've shown the bonds all equally spaced. This is an easier way for us to visualise something that actually exists in 3 dimensions in 2-dimensional space. Now, with this model, we can very easily show the displayed formula, and the displayed formula is just replacing the different circles with the names of the atoms. So I have my carbon in the middle and I've got 4 covalent bonds, and each one of those is attached to a hydrogen. So I've just replaced the circles with the names or the symbols of the atoms that they represent. So we call this a displayed formula. And a displayed formula is just a way of showing our 3D structure as a 2-dimensional shape. The other formula that you're going to come across much more frequently is the molecular formula, and this is just saying how many atoms of each type are there in this molecule. So the molecular formula in this case is just going to be CH4. This is telling me that there are 4 hydrogen atoms and there is 1 carbon atom. We tend to put the carbon atoms first because they're in the centre of the molecule. So this here is your molecular formula. Okay, so I have my molecular formula here and I've got my displayed formula here. These are different ways of showing hydrocarbon molecules, and you need to be able to recognise all these different ways, including the 3D model that is shown in the photograph. There are other things that you need to be able to recognise. So we know that this is an alkane because when we look at the name of the alkane, we can see that it ends up with ane. All of the alkanes, they have ane in their name, so they end with ane, and that tells you that it's all going to be single covalent bonds and you're going to have carbons in the middle. Now the prefix here, the meth, the prefix always means 1, and that refers to the number of carbons. So when we're talking about carbon chemistry, meth means 1. Okay, so moving on to the second molecule in the hydrocarbon family. This is ethane. So again, we've got the ane that tells us it's an alkane, and this is the feature of alkanes is that it's all single covalent bonds. So we've only got 1 rod joining each of our little balls in our model. So ethane is an alkane. We can also see that here we have eth, and that is always going to mean 2 when we're looking at naming of hydrocarbon molecules. Now we can draw this structure in different ways. So we can again draw our structure as if we've squashed it flat on the page, and here I've got my 2 carbons, and each one of those carbons is surrounded by 3 hydrogens. So this is showing from my 3D shape I've got a 2D shape. So 3 dimensions into 2 dimensions, and I've just squashed it flat on the page and rearranged everything so it stands out nice and clearly so that the bonds are equally spaced. What I can do now, I can replace, again, as I did before, I can just replace the different coloured circles with the symbols for the atoms that they represent. So I've got my carbons in the middle, and it's really important that you start with the carbons. Okay, so always start with the carbons when drawing these molecules, and don't forget the bonds in between them. This is the most common place that people go wrong when drawing these formulae. So when drawing the displayed formula, people very often forget this bond in the middle here, and that's very important. So you can see that I've just added the hydrogens around our ethane molecule. And again, this is our displayed formula. So remember, there are different ways of showing the formula, and this is our displayed formula. And then again, we can have our molecular formula, which very often we just refer to as the formula. So our molecular formula is just going to be C2, because there are 2 carbons, H, and then we can count them, there's going to be 6 carbons. So it's C2H6, and that is your molecular formula for ethane. Okay, so the next hydrocarbon in our family of alkanes is propane. Notice again we've got the ane, and then prop, or the prop, means 3 when we're looking at naming hydrocarbons. So prop or prop means 3. So again, I can draw the formulae for this. So I'm going to take my 3-dimensional shape, and you'll notice that it ends up a little bit bendy. And this is just because of the way that the bonds actually arrange themselves in real space. They don't arrange themselves in nice straight lines. So it's a little bit of a bendy shape, but I'm going to make it into a nice flat shape when I squash it flat on the page. Okay, so I've got my 3 carbons in the middle, and again I'm drawing those first, and then I'm surrounding this by hydrogens. Now, because each carbon can only make 4 bonds, you'll notice that my carbon in the middle has only got 2 hydrogens, because it's also attached to 2 other carbons. So when I write my displayed formula, I've got carbon, 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 and I've put the bonds in between as well. And then I surround this by hydrogens. So I've got all of my hydrogens, so 3 hydrogens on each carbon on the end and 2 on the one in the middle. And then I can do my molecular formula as well. So this carbon is C3, and then we're going with H, and you can count them, it's 8. Hopefully by now we're seeing some patterns. So this is the next one in our family, and this one is called butane. Okay, so butane, and again we notice that ane, and again we've got our prefix, and but is always going to mean 4. Okay, so when we're looking at butane, again I can squash this down. You can see it's ended up as rather a wiggly molecule. I can squash this down and hope that I don't run out of space, and I can join all of my carbons up, and around them I'm going to attach my hydrogens. So I've got 3 hydrogens on the ones at the ends, and then 2 on the ones in the middle. And hopefully you can see all of the carbons in the 3D model, and you can see where they've all gone to in my 2D model. So from my 3D to my 2D, hopefully you can see where all of the hydrogens and the carbons have come from. It can be a little bit difficult in our 3-dimensional photos, and that's why we often show things as 2 dimensions, as if we've squashed them flat on the page. So again, I'm going to draw my displayed formula. So I've got my 1, 2, 3, 4 carbons in the middle, drawing them with the bonds in between, and then I'm going to put my hydrogens around them, making sure that each carbon has 4 bonds. Okay, so I've got my hydrogens. Now this equates to 2 hydrogens for each carbon plus 1 on each end of the chain. Okay, so again, my molecular formula here, I've got 1, 2, 3, 4 carbons, and with my hydrogens, it's becoming a little bit difficult to count all of the hydrogens. So I've actually got 10 hydrogens here, but this is where we start to think a little bit about patterns and how we can work out the formulae without having to count everything. Okay, so here we've got a summary of our displayed formulae and our molecular formulae. Now I can see it is actually a little bit hard to see where these formulae separate. So I'm just going to draw a few little lines in here so you can actually see where these separate, because it does get a little bit complicated. But what I want us to have a look at, I want us to have a look at where we're seeing a trend in the number of carbons and the number of hydrogens. So what we should see is that for every carbon, we have got 2 hydrogens plus the 2 on the ends. So for every carbon, I've got 2 hydrogens plus the 2 on the end. So when I look at my ethane, for every carbon, I have 1, 2 hydrogens plus the 2 on the end. And again for propane, 1, 2 plus the 2 on the end. And this is always going to give me the number of hydrogens just from counting the number of carbons. So we actually have a general formula, and this general formula I'm just going to pop in the corner here. Okay, so you can see that I have just put the general formula in the corner here. So the general formula for working out the number of hydrogens and carbons in a hydrocarbon molecule, one of the alkanes, is just by looking at how many carbons are there. So Cn. So first of all, you do have to count the carbons. So Cn, and then N becomes however many carbons there are. So N could be, for example, this N could be 1 if we're looking at methane, 2 if we're looking at ethane, 3 for propane, and 4 for butane. So that N becomes whatever is the number of carbons. And then the number of hydrogens can be worked out by doubling that, because there's 2 hydrogens for every carbon, so it's 2N, plus 2 because there's always 2 extra hydrogens on the end. This general formula is something that you need to learn. So in summary, our alkanes, they have a general formula of CnH2n plus 2. They are hydrocarbon molecules They are covalently bonded with single bonds. And that's important. And a lot of alkanes are used as fuels.